Okay, if they don't have the same base, we've got to make them so they do. So for example, if we were trying to add 1/4 and 5/6, okay, if we're trying to add 1/4 and 5/6, we can't do it because they don't have the same denominator. What is their least common denominator of 1/4 and 5/6? 24 is a common denominator, it's not the least common denominator. 12, okay? 12 would be the least common denominator between 4 and 6. So we've got to turn the 4 into a 12. We've got to turn the 6 into a 12. We do that by multiplying. So let's add that, or let's use that knowledge here. On number 17, we've got 15 over 2x minus 16 over 3x. So they both have x. That's good. They already have that in common. Okay, they both have x, so we're good there. One's got 2x, one's got 3x. So what is the least common denominator between 2 and 3? 6. All right, so just like you would do with fractions, I got to turn that 2 into a 6, so that means I multiply by 3. But if I multiply by 3 in the denominator, what do I also have to do? Multiply it in the numerator. Okay, so that first one I'm going to multiply top and bottom by 3. So what am I going to do the second one? Do I multiply by 3? No, I'm going to multiply top and bottom by 2. So let's see what we've got here. 3 times 5 is 45 over 6x minus 16 times 2 is 32 over 6x. Now I've got a problem just like I was doing. They got the same denominator, so I just subtract, in this case, their numerator. So 45 minus 32 is what? 13 over 6x. At this point, I check and see if I can simplify. 13 and 6 do not have a common factor, so that's it. Again, check it. Check it, check it, check it. Plug the first expression into y1. Okay, 15 over parentheses 2x minus 16 over parentheses 3x. Okay, and then our answer was 13 over parentheses 6x. Go to the table. Our y values match, so we're good. Okay, let's look at number 8. The first denominator has a squared. The second denominator has 8a. Let's deal with the number part first. Okay, the second denominator has 8. The first denominator does not. So that first denominator, we've got to put the 8 there. So we multiply top and bottom by 8. The first denominator has a squared. The second denominator only has a. How do we fix that? Multiply by a. A times a is a squared. So let's check and see what we've got. 8 times 4a is 32a. 8 times a squared is 8a squared. Minus 7 times a is 7a. 8a times a is 8a squared. So 32a minus 7a is 25a over, we don't change the denominator, so it's 8a squared. Can we simplify anything here? What can we simplify? The a's, okay? 25 over 8, they don't have anything in common. But a over a squared, 2 minus 1 is 1. It was bigger in the bottom, so an a goes in the denominator. All right, so those weren't too bad. Let's look at what happens when we get more than just a monomial in the denominator. Okay, let's look at number 9. We've got 5k minus 10 in one denominator and k minus 2 in the other denominator. So the difference when we go from just a monomial to binomials is that in this case, you need to factor the denominators if they are factorable, because look at what happens here. That first denominator, can we factor something in that first denominator? Do those two terms have anything in common? Yes, they're both factors of 5, right? So if we take out a GCF of 5, we're left with k minus 2. Okay, so I factored that denominator into 5 times k minus 2. Now, do those denominators have something in common? They look a whole lot more alike than they did just a second ago. They both have k minus 2. So the only difference between those two denominators is that the second one doesn't have the 5. So we need to multiply it by 5, top and bottom. We don't have to touch the first one. Okay, we do not need to do anything to the first one because it's not missing anything that the other one has. Okay, so let's write down what we've got right now. K squared plus 16 over 5 times k minus 2 minus 4 times 5 is 20. 5 times k minus 2. Now we have the same denominators, so we can combine their numerators. K squared 16 minus 20 is negative 4. So we've got k squared minus 4 over 5 times k minus 2. Okay, the top, k squared minus 4, is the difference of perfect squares. We can factor it. Okay, so once you put them together, you're always looking to ask yourself, can I factor that numerator to see if something will simplify? And we can in this case. K plus 2 times k minus 2 gives us k squared minus 4. Now, it's not always going to simplify. Okay, they are not always going to simplify, but a lot of times they are. So you should always look for that. See if it will factor further after you combine them to simplify. So we're left with k plus 2 in the numerator and 5 in the denominator. All right. So number 10. Number 10. It looks like those denominators are very, very different, doesn't it? Y plus 8 and y squared plus 11, y plus 24. We can't factor y plus 8. There's no GCF. It's just a binomial. We can't factor that one. But I bet we can factor that second one, right? How do we factor that second denominator? 8 and 3. Y plus 8, y plus 3. And that's great because now the denominators have something in common. So the first one needs the y plus 3. So top and bottom, we multiply by y plus 3. So let's go ahead and distribute that. Y plus 3 times 7 gives us 7y plus 21. Leave the denominator in factored form. Okay, leave the denominator in factored form. Plus, we didn't have to multiply the second one by anything, so it's just got the 35 up there. So now they have I didn't write them in the same order, but they have the same denominators. So we can combine their numerators. This one is by adding. I don't know why my pen keeps on going berserk here. Okay, 7y, 21 plus 35 is what, 56? What do I ask myself right here? Can I factor? Can we factor it? Yeah, we can. We can take out a GCF of 7. And guess what it leaves us with? Y plus 8. So we've got 7 over y plus 3. Okay? All right, we've got a few more examples of this because this is tougher. Okay, let's do a few more examples, and then I'll let you practice with some. Figure out where I'm at here. All right, here we go. Number 11. We've got a factor. Okay, factor in the denominator. X squared plus 5x plus 6. X plus 3 times x plus 2. Okay, and that's good because they now both have an x plus 2, so that just means that the second one needs an x plus 3, top and bottom. All right, so we've got x squared minus 5 over x plus 3, x plus 2, plus 1 times x plus 3 is just x plus 3, right? Multiplying by 1 doesn't change anything. They have the same denominator, so now we can add their numerators. X squared plus x, negative 5 plus 3 is negative 2. Can we factor the numerator? Yes. Let's use the denominator to help us out. Is x plus 3 a possible factor of x squared plus x minus 2? No. How about x plus 2? Yeah, could be. So if that was positive 2, what needs to go in the other set of parentheses? A negative 1. Does it work? Plus 2x minus x gives us plus x. So we're good. You should always check because sometimes these don't simplify, but what has happened so far? Every single one of them has simplified, have they not? There's been some kind of simplifying that we've needed to do. Alrighty, let's keep going. Number 12. M squared minus 4. Difference of perfect squares, right? If you don't recognize that by now, you got a problem. Okay, you got to recognize those difference of perfect squares. Now, I haven't done this up to this point, but can we factor that first numerator? We can, right? M plus 3 times m plus 2. M plus 3 times m plus 2. Now, the reason why I haven't done it up to this point is because none of our numerators have been factorable, okay? X squared minus 5, close to the difference of perfect squares, but 5 is not a perfect square, okay? We haven't run into one that we have been able to factor, but we can factor this one. So, can I simplify something in that first expression? Do I have anything in the numerator and in the denominator of the first expression? Yeah, I got an m plus 2 in the top and in the bottom. So go ahead and simplify that because look at what happens when we do that. We've got m plus 3 over m minus 2 left. Doesn't that mean we have the same denominators? We got common denominators. We didn't even have to get a common denominator. It was already there. It was just hidden in a bigger expression. So then we can combine the numerators. M plus 3 plus 2 is m plus 5. Now, if you didn't recognize that, not the end of the world. It would still work out if you multiplied the second one by m plus 2 in the top and in the bottom. You would just have to factor and cancel after you added them. Okay, I didn't have to factor and cancel after we added them because there was nothing to factor and cancel. Okay, so it's not the end of the world if you don't see it right off the bat. Okay, let's look at number 13. W plus 1, W minus 7, not the same. Be careful, those W's are not the same, okay? You have to look at this as this is a term, this is a factor, and this is a factor. So the first one needs what the second one has, the W minus 7. The second one needs what the first one has, W plus 1. Top and bottom. So let's save ourselves some space and go ahead and distribute. Distribute the 5. 5W minus 35 over W minus 7 times W plus 1 plus, distribute the 8. 8W plus 8 over W minus 7 times W plus 1. Same denominator, so we can combine their numerators. 5w plus 8w is 13w. Negative 35 plus 8 is what, negative 27? Yeah? Can we factor anything from the numerator? 13's a prime number. So this is it. We finally ran into one that did not that did not factor and simplify after we add them together. Okay? So a lot of times they do, sometimes they don't. A lot of times they do, but sometimes they don't. Let's look at number 14. Okay, we're almost done. I know I've done a lot. I've done a lot of talking, but there are a lot of different scenarios here we got to worry about. Number 14, we've got b plus 3 and b. Those b's are not the same. Okay, the first one is b plus 3. You got to look at that as its own factor. So that first expression needs just a plain b. The second expression needs the b plus 3. Okay, that one, the ones like these tend to throw people off because they want to count the b's the same, and they just want to multiply by 3, but that doesn't get you to have the same denominator. Okay, so b times b is b squared. We've got b squared over b times b plus 3. Minus, let's distribute the 4. 4b plus 12 over b plus 3. So we have the same denominators. Let's combine their numerators. B squared, it's a minus, so minus 4b minus 12. Minus 4b minus 12. People mess up on that all the time. Okay, so now we're looking to see, can we factor and cancel? We can factor. Does it cancel? How does it factor? We would love if it was 3 and 4, right? Since we've got a 3 in the bottom, but is that going to work out to give us a minus 4 in the middle? 3 and 4 are not going to give us a minus 4. It does factor, okay? It does factor. B minus 6, it's going to show, okay, B minus 6 times what? B plus 2. So it does factor, but nothing cancels. So we'll just leave it. I like it in factored. Factored form is better anyway, so we'll just leave it. Okay. We got 2 more to do, and you don't have to listen to me for a while. Okay, 2 more. Make sure we got this, because I think y'all can get this. I really do. It's tough, but I think y'all can get this. Okay, if you see enough examples. All right, number 15. Woo! This one looks a little different, doesn't it? Okay, so first denominator. Can we factor it? Yes. 4 times p minus 5, right? Second denominator. Is it factorable?
Yes.
Yes. P minus 5, p minus 3. That's a good thing because now they share p minus 5. I think it's helpful to kind of underline what they have in common so I can just look at, okay, well, what are they missing? So the first one doesn't have the p minus 3 that the second one does. So top and bottom, p minus 3. What is the second one missing that the first one has? 4. Top and bottom, multiply by 4, put some parentheses around that p minus 6 because we're going to have to distribute that 4. Okay, so 2 times p minus 3, 2p minus 6, over. I like the GCF to come first. Put the 4 in front, then the p minus 3, then the p minus 5. Technically, the order doesn't matter, but it's best to put just plain constants in front. Okay, plus, distribute the 4. 4p minus 24, over. Put the 4 in front. Might as well write it in the same order that the first one's in. Why not, right? Because they've got the same stuff, they might as well look exactly the same. So, same denominators, let's combine the numerators. 2p plus 4p, 6p. Negative 6 plus negative 24, negative 30. Can we factor the numerator? Yep. GCF of 6. So what simplifies? P minus 5. How about with 6 over 4? Can we simplify? 3 over 2. Those are both divisible by 2. So we've got 3 by itself in the numerator and 2 times P minus 3 in the denominator. Did a little bit of work there. Okay, one more and we got this. Okay, first denominator, 2r plus 8. What do we need to do? Factor, okay, how? Take out a 2 as a GCF. R plus 4. How about that second one? Somebody besides Jason. Second denominator. Take out an R, right? R plus 4 is what we're left with. Well, that's good because they have something in common. Okay, they have something in common. So what's the first one missing? Just an R. What's the second one missing? The 2. Very good. Y'all got this. See, y'all are smart. Y'all really are smart. R times R is R squared. Let's write that as 2R times R plus 4 in that denominator. Okay, minus 8 times 2, 16. 2R over R plus 4. Okay, same denominators. Let's combine the numerators. Don't lose the fact that that's a minus. Difference of perfect squares. R plus 4, R minus 4. What simplifies? R plus 4. We're left with R minus 4 over 2R. That's it. Okay, don't be tempted to simplify too much. Can't cancel the R's. Can't cancel 4 over 2 because of that minus. Okay, you were able to simplify here in number 15 because we were multiplying right there. You can simplify when you're multiplying. You're not multiplying anymore in this problem, so we can't simplify. Okay? All right.